Okay, I know on that last one we didn't use Desmos to go back and check it, but in this one we are going to graph it and verify it and check it. So we've got a lot of examples that I'm going to go through, so just bear with me. We are going to be graphing things. These videos might be a little bit longer than what you're normally used to. You can always look and see, which problem that you want to get an example of. I'm going to try to only do 2 problems per video, so at the most. Okay, so f of x equals x plus 3 quantity squared over x minus 5. Now, this here, you notice, is that we are going to have an x squared function, or an x squared term. If we multiply that through, I could FOIL this. I could go ahead and multiply, if I wanted to, x plus 3 times x plus 3, but I can easily see that really the only thing I need to take care of is what is the degree of the function, and x times x is x squared. So therefore, the degree of the a of x, so the degree of a of x is 2, and the degree of b of x is 1. So we can figure out what the degrees are, so that gives us some idea of asymptotes. Let's find the vertical asymptote, since that's what we're going to look for first. We're going to set the denominator equal to 0. So in this case, x equals 5 because we add 5 to both sides. So there is our vertical asymptote. We look at our horizontal asymptote. And our horizontal asymptote, there is none. And the reason why there's none is because a of x degree is greater than the b of x degree. And then the oblique asymptote, if the degree of a of x is only 1 greater than the degree of b of x, which we can see it is, there is an oblique asymptote. So therefore, what we would do is we would divide, and so I know I say zeros here. I'm going to kind of cross that out because we're going to do the division first. So we're going to do x minus 5 goes into, and now I do have to multiply this out. So notice I have x plus 3 times x plus 3. I'm going to go ahead and multiply that out. I get x squared plus 3x plus 3x plus 9, right? So that's foiling all over x minus 5. So you notice I get x squared plus 6x plus 9. So I get x squared plus 6x plus 9. So now I can see what I need to divide into. So this is going to be long division. We've done other types of division as well. So there's many different ways to be able to do this. I'm going to go ahead and use long division just to kind of show you what to do here. So when we do long division, we just look at this x and how many times does it go into x squared. So we would do x squared divided by x, and of course that is equal to x. So we draw an x right up there. Okay, so now long division tells me that I multiply, and again, I've gone through this method before, so this should just be a refresher. It doesn't mean that you have it memorized, but it should be a refresher. So x times x is x squared. X times negative 5 is negative 5x. I'm then going to change the sign of both of them. Okay, notice I'm changing the sign of both of them, so that negative is gone. So I have x squared minus x squared, which should happen. Those should cancel. And then I have 6x plus 5x, which is 11x, and then plus 9. Okay, and that 9 I just brought down. Now, we divide 11x divided by x, which of course is just 11. It's positive, so we do positive 11 up here. So I do 11 times x, which is 11x. So now I multiply it by both of these. And then minus 55. Okay. And when I do that, of course, this goes to 0. My number here becomes negative 46. I think that's right. So negative 46. So therefore, my oblique asymptote slope actually occurs right at this particular point. So now we're going to go ahead and look at how to graph these things. So I'm going to stop it for a minute so I can type all this stuff in to Desmos ahead of time. And that way then you don't have to watch me do that. So I'm just going to pause it. Okay, now let's go ahead and go back and look at some things. So I've typed in the equations. I'm going to explain these in a minute. Here's my original equation, f of x equals x plus 3 quantity squared over x minus 5. And then I added another equation here, and let me explain where that comes from. So you'll notice here that my original equation was x plus 3 squared over x minus 5. And then when I did this division, I ended up with x plus 11. Now notice that I had this remainder here that I circled. We're going to ignore that actually, and we're going to look at just x plus 11. So here is my oblique asymptote, x plus 11. So if I look at this here, you can see my function, you can see my oblique asymptote. I'm going to go ahead and draw the asymptote. You can see it right here. It's this line. And then I'm going to go ahead and draw that one and look at how that function, you'll see that right there, has that oblique asymptote. Now, we're also going to draw one other thing because I want you to see it. We have a vertical asymptote at x equals 5. So what I'm going to do here is I'm going to also say x equals 5. And notice that we have this one here. Now notice how this function is never crossing either of those lines. This one right here, this oblique, and also this vertical. So you can kind of see that as we go through it. Okay, so that takes care of that problem. And actually, I'll just stop the video again. So in this one now, same kind of thing. So notice that the degrees of a to the x. So for a to the x, the degree is 2 from this 2 right up here. And for b of x, it is 1. And that's from this one right here. Okay, asymptotes. We have a vertical asymptote located at 3x plus 4 equals 0. Subtract 4. So 3x equals negative 4. Divide both sides by 3. X equals negative 4/3. Okay, so that's where our vertical asymptote is. We have no horizontal asymptote. We do have an oblique asymptote. So the reason why I know we have an oblique asymptote is because it's 1 greater than. So we're going to do that division again. This is good practice. So we have 3x plus 4 divides into 2x squared. Now, whenever we're doing division, notice that there is no x term here. So we're going to put plus 0x plus 5. So again, this is a rule that we learned back in the day, back last semester. And again, reason why you learn those kinds of things is because you're wondering, well, when are you going to use it? At least in the math class, this is when we're going to use it. Okay, so now what do? We do 2x squared divided by 3x. And so that is 2/3 x, right? One of the x's cancels. We have 2/3 x. And now we're going to multiply it. So we're going to multiply it by 3x. So we get 2x squared, which should happen. These two should always be the same. And then we have 2/3 x times 4, which is plus 8/3 x. Notice it's getting a little sloppy with all the different values here. I'm going to make this negative and this negative, okay? Because we're subtracting them. So we have 2x squared minus 2x squared, which of course goes to 0. We have negative 8/3 x plus 5. Now notice that we have this function here. We still have to find one more number over there, but we will figure this out. So then we're going to do 8/3, we're going to do negative 8/3 x divided by 3x. So notice it's getting pretty messy. So as we start going through some of these problems, it can definitely happen, but shouldn't curtail you from doing anything else. Now notice that the x's will cancel, so we end up with negative 8/3 x over 1/3. We're then going to reciprocate and multiply. That's a math rule. So we have negative 8 over 9. So that would be my answer, negative 8 over 9. Okay, so here is my oblique asymptote. And now we just have to find any zeros. So notice in this particular case, we can look for zeros in here. I'm going to show you that there are no zeros, because if we do 2x squared plus 5 and we set it equal to 0, we're going to subtract 5 from both sides. We get 2x squared equals negative 5. And we can't take the square root of a negative number and have it be real. So what this is telling me is that there are no zeros. So it should never cross the x-axis. Okay, so we're going to kind of get an idea as we go through this and see that that function never happens. So that is definitely a possibility, and we'll see how that works. Okay, so we're going to go ahead and draw those up. I'm going to pause it again and just write in the equations. Okay, and now coming back to this, and you can refer to your notes on this. Here is my function. Notice I just kept these up here. Here's my function. Here is my oblique asymptote. Here is my vertical asymptote. I'm going to open up the vertical asymptote first. So notice that negative 4/3 is right there, so it can't cross that particular one. We can go through, which is nice, and we can, I think that's how you do it, yeah. So we can tell it to put it like that. We're going to do the same thing on this one. This is our asymptote. We are going to, if you left click on it and then go over here, we can see that one. And then we're going to look at our graph. And notice that our graph never touches those asymptotes. So it's nice when we can see that after doing all the math work and we have a good prediction about what it's going to look like. So these are the kinds of concepts that I want you to understand. And that's it.